Hi, my name is David Hurd, and this is Lab 4 Circuits. In this lab, we'll be using the principles of conservation of energy, conservation of charge, Kirchhoff's node and loop rules, and Ohm's law, to name a few. The purpose of this lab is to predict the behavior of resistors and capacitors in series and parallel, and to observe and understand their behavior. What we'll see in this lab is that the simulated values that we get from our model match the calculated values, meaning that for the most part, our simulation is an accurate model of electrical relations. The system in our experiment is the circuit, and the surroundings is everything else, which in code means not anything. The model we'll be using is an ideal online simulation, and we're assuming that the resistance of wires is negligible along with the resistance of an ammeter. In the first part of the experiment, we have two batteries of 1.5 volts each put in series with two ammeters and two resistors, as you can see here. Now, the prediction is that both currents will read about 0.0204 amps. And what we see is that is the case, and that result was got by Kirchhoff's rule. It explains why they're the same, and Ohm's law gives you that answer. When you reverse the ammeter, it actually gives the negative value. And when we remove one of the ammeters and replace it with a voltmeter, we see that it has 3 volts and 0 amps. Now in the second part, we remove both of the new voltmeter and the ammeter, and we look at the voltage being used by each component. What we see is that from A to B, there are 3 volts, and that is across the battery. From C to B, there are 0. From C to D, there is a drop of 0.96. From D to E, there's also 0. From E to F, there is a drop of 2.04, and then everything else is 0, and which means that there is a total net change of 0. Now this does assume that the wires are negligible, and in a real situation they won't be. Now in the second part, we looked at capacitors and a resistant bulb. Now when the bulb and the capacitor were in series, it began to charge, making the bulb glow and slowly dim as the capacitor gained charge. And when the battery is disconnected and the circuit was put back together, the same thing happened, but this time because the capacitor was acting like a battery and discharging. The 10 ohm bulb had a discharge time of 10 seconds and the 20 ohm 18. Possible error in this is human error, just copying, saying things incorrectly, or incorrect assumptions or measurements. Now, what if we used a real ammeter? Well, the real ammeter would have some resistance and take up some voltage, meaning that the total current would be different because the total resistance would be different. Now, what if we used real components, like real wires? Well, real wires would also have the same issue where they would have some resistance and take up some voltage. And if they were real wires, the capacitor would actually charge slower because of that resistance. Thank you so much for watching. That is Lab 4.